So here's what we've got. If you have a point x comma y, the distance from the origin to that point is going to be the square root of x squared plus y squared. That's the distance formula or the Pythagorean theorem. And our definitions of the trigonometric functions now are that if you have an angle in standard position and a point on the terminal side of the line, of the angle, terminal side of the angle, then the cosine is going to be the x coordinate divided by the radius. The sine is going to be the y coordinate divided by the radius. And the tangent is going to be the y coordinate divided by x. The reciprocal functions, secant of theta, is going to be the reciprocal, r divided by x. And the cosecant is going to be, of theta, is going to be the reciprocal again, r divided by y. And the cotangent will be the reciprocal of the tangent, which is x divided by y. And as long as we were doing these, I thought for some of them I would show you how to get the angle measurement, since we have been talking about the inverse functions, inverse trig functions. The way you would get that, or one way to get it, would be to say, well, look, if the tangent of theta is y over x, then whatever angle has the tangent of y over x should at least give us a clue as to what theta is. So if we take the inverse tangent of y over x, that will tell us one of the angles that has the tangent y over x. So that might give us the measurement of theta, or it might not. If you'll recall, we had to restrict the range of the inverse tangent in order to make it a function, and we had to restrict it to this place right here. That meant if your angle was over here, you're going to have to think a little bit. It wasn't going to show up in your calculator. The slope of this, remember, tangent is slope and slope is tangent. So the slope of this is going to be the same as the slope of this. When you put this slope in to find out what the degree measure is, your calculator will give you this angle measurement right here. So it'll give you this negative value, but you'll know that's wrong because that's not where the terminal side of your angle is. You have to add 180 degrees. You'll see what that looks like in a minute. This is problem number 7 on page 72. Okay, and you're given the points 7, 11. If you do 7 squared plus 11 squared, you get 170, and if you take the square root of that, you get square root of 170. The cosine is going to be x over the square root of 170, and when you rationalize that denominator, you get 7 square root of 170 over 170. That's the cosine of theta. The sine of theta is going to be the y coordinate over the radius. So it's 11 over the square root of 170. And when you rationalize that denominator, it's 11 square root of 170 over 170. And the tangent is 11 over 7, y over x. If we come over here, if we just sort of roughly plot the point 7, 11, the terminal side of the angle is going to be in the first quadrant. And if we put the inverse tangent of 11 over 7 into a calculator, we get approximately 57.53 degrees. And that's a reasonable answer for this, because it's also in the first quadrant. So let's go to the next problem. problem number 8. If you're given the point 4, comma 1, which is this one right here, then the square root of 4 squared plus 1 squared is equal to the square root of 17. And the cosine of theta is going to be the x-coordinate 4 over the square root of 17, which is 4 square root of 17 over 17. The sine of theta is going to be 1, the y-coordinate, over the square root of 17, and that rationalizes to square root of 17 over 17. And the tangent of theta is 1 over 4. So the instructions said just give us the cosine of theta and the sine of theta and give us the exact values. So we're done with that as far as it goes. But again, I wanted to show you how to get the angle measurement. If you come over here, right, 4, comma 1 is also in the first quadrant. So you're going to wind up with theta is equal to the inverse tangent of 1 over 4. And that's approximately 14.04 degrees. You just get that by putting 1 over 4 in your calculator and getting the inverse tangent of that number. Moving on, let's go to number 9. You're given negative 2, comma 5. If you put those into the Pythagorean theorem, you get a hypotenuse of square root of 29. That's also the length of r. So the cosine of theta is equal to negative 2 over the square root of 29. And when you rationalize that, it's negative 2 square root of 29 over 29. Sine of theta is the y-coordinate 5 divided by r, which is 5 over square root of 29. And that's equal to, after you've rationalized it, 5 square root of 29 over 29. The tangent, y over x, negative 5 over 2. Let's go over here and see what the angle looks like. So if the terminal side is over here in the second quadrant, this is the angle right here. Take the inverse tangent of negative 5 over 2. We wind up with negative 68.2 degrees. Okay, that's not going to work. Why? Because negative 68.20 degrees is down here. And if you remember what we said that we had restricted the range of the inverse tangent to this place right here. So when you put in negative 5 over 2, of course, that's going to be the slope of the terminal side. Negative 5 over 2 is a negative slope. It's going to go down this way. And this is what you're going to get, the negative 68.2. It's that. But this isn't what you have. What you have is the other side of this going up that way. The slope of this is the same. So this is the angle that you're actually looking for, this one here. It's 180 degrees. It's exactly the opposite of this ray here. So we're adding 180 degrees to it and getting 110.80 degrees. So let's look at number 10 and figure out what we're going to do here. For number 10, the point that we're given is negative 6, comma 9. And the first thing we need to do with that is figure out what the r value is, the distance between the origin and the point. And the distance between the origin and the point is square root of negative 6 squared plus 9 squared, which is square root of 36 plus 81, which is square root of 117. 117 can be factored as square root of 9 times 13. Square root of 9 is 3, so I can take that out, and it simplifies to 3 square root of 13. So when I do the cosine, sine, and tangent, I'm going to take the x value, negative 6, and divide it by the r value, 3 square root of 13. That simplifies to negative 2 over square root of 13, and rationalizes to negative 2 square root of 13 over 13. The sine of theta will be the y value 9 over the r value 3 square root of 13. That simplifies to 3 over square root of 13 and rationalizes to 3 square root of 13 over 13. That by itself is the official answer to number 10. But again, I'm going to take it one step further and say here's the tangent of theta, which is negative 9 over 6. I'm going to look at that and simplify it to negative 3 over 2. I'm going to draw the angle and see that the terminal side of the angle is actually over in quadrant 2. So when I put the inverse tangent of negative 3 over 2 into the calculator, it gives me negative 56.31 degrees. And I know that can't be the right answer because the terminal side of this angle is in the second quadrant. So I add 180 to it and I get 123.69 degrees. Okay, so that's number 10. There's number 11. Okay, we take 4 comma negative 8, use those numbers to get r. We get square root of 4 squared plus negative 8 squared. Turns out to be square root of 80, which reduces or simplifies to 4 square root of 5. So cosine of theta is 4 over 4 square root of 5, which simplifies to 1 square root over square root of 5, which rationalizes to square root of 5 over 5. The sine of theta is negative 8 over 4 square root of 5. That simplifies to negative 2 over square root of 5 and rationalizes to negative 2 square root of 5 over 5. The tangent of theta is negative 8 over 4, which reduces to negative 2, simplifies to negative 2. Here's what the angle looks like. Okay. Angle looks like that with the point at 4 comma negative 8. And that means that we are going to get the right answer out of the calculator this time. When we put in the inverse tangent of negative 2, we're going to get approximately negative 63.43 degrees, and that's a reasonable answer for theta. Okay, here's number 12. We get 8 comma negative 3. Take the square root of the sum of the squares. We're going to get square root of 73. Take the x value and put it over the r value, and then rationalize the fraction. We're going to get 8 square root of 73 over 73. Do a similar thing for sine of theta. We take negative 3, put it over square root of 73, and then rationalize it. Negative 3 square root of 73 over 73. And then to get the tangent of theta, it's negative 3 over 8. Again, we're going to go over here. We're going to look at what the angle looks like, 8 comma negative 3. Sure enough, that's in the fourth quadrant, which means we're going to get a straight answer out of the calculator. When we put in the inverse tangent of negative 3 over 8, we wind up with negative 20.56 degrees. And let's do the next one. Oh, this one's a little busy. That's because this one's interesting. Okay, r is square root of negative 24 squared plus negative 7 squared, which is equal to the square root of 576 plus 49, which is equal to the square root of 25, which is actually a perfect square. The square root of that is 25. So if you notice, we have a Pythagorean triple here, 3 whole numbers that satisfy the equation a squared plus b squared equals c squared. 7, 24, and 25. Okay, that is a Pythagorean triple, so anytime you see that, if you remember, you can jump straight to the answer. In this case, the cosine of theta is negative 24 over 25. The sine of theta is negative 7 over 25. And the tangent is simply the y value over the x value, and that's 7 over 24. When we do that angle, it's going to be in the third quadrant, so we're going to have to do a little bit of extra work. What does that mean? That means when we put in the inverse tangent of 7 over 24, we get 16.26 degrees. Okay, that's an angle that's up here in the first quadrant. That's not going to work for us. We have to add 180 degrees to get over here in the third quadrant, and that's negative 24 comma negative 7. And the degree measurement is 196.26 degrees. Number 14 is negative 3 comma negative 4. And if you didn't recognize that as a Pythagorean triple right away, put in the squares of those two numbers and add them together. You get the square root of 25, and that's 5, because 25 is a perfect square. 3, 4, 5 is a Pythagorean triple. So the cosine of theta is negative 3 over 5. The sine of theta is negative 4 over 5, and the tangent of theta is equal to 4 over 3. So where does that put us? Okay, once again, we've got an angle with the terminal side in the third quadrant, so we won't get a straight answer out of the calculator. When we ask it what is the inverse tangent of 4 over 3, we get approximately 53.13. That's an angle with the terminal side in the first quadrant, so we have to add 180 degrees to that, and we get theta is approximately 233.13 degrees. For the next problem here on page 78, 4 comma negative 3 is the angle measurement. That puts r again at 5, because 3, 4, 5 is a Pythagorean triple, which means the cosine of theta is 4 over 5, the sine of theta is negative 3 over 5, the tangent is negative 3 over 4, and the reciprocal functions are secant theta is 5 over 4, cosecant theta is negative 5 over 3, and the cotangent of theta is negative 4 over 3. Again, there's nothing to be done here except put the numbers in to that. Those are the definitions, and we're done. Number 8, negative 12 comma 5. When we put those numbers in, that's also a Pythagorean triple, 5, 12, 13. So we can jump straight to cosine of theta is equal to negative 12 over 13. Sine of theta is 5 over 13. Tangent of theta, negative 5 over 12. And the reciprocal function secant of theta is negative 13 over 12. Cosecant theta is 13 over 5, and the cotangent of theta is negative 12 over 5. Again, those are the answers to the question. Going to number 9. What do we got here? Negative 5 comma negative 7. That means we're going to say that the radius is the square root of negative 5 squared plus negative 7 squared. Okay, that's not a Pythagorean triple. We wind up with square root of 74, and we can't simplify that at all. So the cosine of theta is negative 5 over square root of 74, and that rationalizes to negative 5 square root of 74 over 74. Sine of theta is negative 7 over square root of 74, which rationalizes to negative 7 square root of 74 over 74. And the tangent of theta is 7 over 5. We're going to go over here to the reciprocal function. Say the secant of theta is equal to the negative square root of 74 over 5. The cosecant of theta is negative 74 over 7. The cotangent of theta is 5 over 7. Again, just taking the reciprocals of the first set of trig functions. And then finally, 2 comma 3, that's also not Pythagorean triple. The value of r is square root of 13. Cosine of theta is 2 over square root of 13, which again rationalizes to 2 square root of 13 over 13. Sine of theta rationalizes to 3 square root of 13 over 3. Tangent of theta is 3 over 2. The reciprocal functions are secant of theta, square root of 13 over 2, cosecant of theta, square root of 13 over 3, and cotangent of theta, 2 over 3.